Hi fellow enthusiasts, welcome to my channel. Let's go into today's video and we're going to come back at the end to wrap it up. In today's episode, we're going to be looking at how to add sensors to the Nextion project. Today we're going to be using an ultrasonic distance sensor. For this, we've added two pins, the trigger pin and the echo pin, and we have some variables for duration and for distance, and then we have another variable for just a boolean to let us know when some conditions are met and when those conditions are no longer valid. So here in the setup, we've made it a little bit more modification here. I've added the pin mode for trigger and for the echo. So the trigger pin is the output and then the echo pin is the input. I don't think we made much changes here. We already have the serial begin from the last week's project. And then in our void loop, in order not to confuse what we've already created here, we just added a function that we're going to call later. We call it distance measure. So we're going to call this function. The rest of the things remain about the same. So when we call this function, here is a function at the bottom here. So this is what you do if you don't want to confuse your codes or mess up with your codes. Just declare a function, then create a function at some point later in your program. So here we've after the trigger pin, we pull it down first and then we delay it. Actually, you don't need this, to be frank. Then we'll do a digital write to the trigger pin high, delay for 10 microseconds, and then you write it low, right? And then you listen. So the pulse will come in and from the echo pin, and then you measure the distance. Distance is calculated from duration multiplied by time over 2. Now this is from, I'm just going to write it here, but I will just for the sake of it. So speed is equal to distance over time. Distance over time. And so that's where we get this formula from. So from here then, duration, which is the time, distance over duration, let's just call it duration. So from here you can calculate the duration multiplied by speed is equal to distance. You can do it the other way around as well, just like we did it before. So distance is equal to duration multiplied by speed. Now we know that the speed of sound is about 343 meters per second. So that's how we got this value here. So when you convert this to microseconds, and because we're keeping this on for only 10 microseconds, so when you convert that to microseconds, you get this value. So this is the value, the amount it will travel in 10 microseconds. So this value in centimeters, right? We're dividing by 2 because you're calculating the distance to and fro. Because the signal goes out, hits an obstacle, then comes back, and then you measure that distance. So the distance for one way is going to be half of that. I'm trying to make this a little bit cleaner, so let's just do this. Alright, so that's how we got the value for the distance we're using, right? So then no, I don't need that there. I need this value. Yeah, so that's how we got this value, if you're wondering. Then we print out the distance and the value, right? Put distance, then we put the value. So we delay for 500 microseconds. All right, so here's the logic that we're using now. So we have to do a little bit more logic. So here we say when if the distance from the sensor to the obstacle is less than 10, set the angle of the servo motor to 180 degrees. So you're just opening it up fully, and then you write the value to the servo motor. You turn the light on, and then you write on the display, on the Nextion display, you put this value: someone is at the door, motor angle. Then you display the motor angle. You can write whatever you want here. These are just examples. Then you put that value on the Nextion display, and then on the serial monitor you print out someone is at the door. You can print out whatever you want. Did it for a second, then you set the value. This value can actually be here, but you set the value enter in equals to true because someone has entered the boundary or the radius that you've set. Now, if you remember at the beginning, we have declared that enter value to be false. So now that condition has changed now. So the enter value is now, where is it? The enter value is now true. Where is the value? Yeah. So the enter value is now true. And if it is true, we are saying if the distance is greater than 10, in other words, the intruder or someone within the perimeter has left, either entered the room or left the room, and the condition, the boolean, is true, which we have met by this condition. When this is true, set the angle to 0, write that angle to the servo motor, and then turn the light on, and then say never mind, the person has left, and then you can display whatever you want. This is again just example. And then once that happens, you say that enter is now false, right? Because the guy has exited, right? The distance is no longer less than 10 but greater than 10. So you say enter is false, the perimeter is no longer breached, thus the person is no longer within the perimeter. So you write it as false. This is important because you don't want this door to be closed permanently. You want to be able to open it again when someone approaches the door. And then we have other conditions. So when I press the center button, the one that normally gave me 80 degrees, I want to set the enter to false because I don't want the door to be closed all the time. So because when it is false, if you remember here, when it is false, it will not enter here. It can only enter this condition when this is true. This condition is to close the door. So when this is false, then you can never enter this logic. So that's what we did here. So whenever you press the button, whenever you press any of the buttons on the Nextion display, I'm going to show it on the screen on the right hand side of the screen, but whenever you press that button, you set the enter to false. You don't want to close the door permanently. We have it in all the button functions. So we have 3 button functions. For when it is less than 180 degrees, we set it to false. When it is the center, when we're going to set it at 90 degrees, we set it to false. And when we're going to set it to, when it's greater than 0, we also set that enter to false. Setting it to false, again, according to this logic, and it shows that the door is not permanently closed. Alright, so let's show you how this works. Alright, so you can see the Nextion editor here, and then I have the servo motor mounted on this device, desktop device. So let me just put something, shiny object, so you can see the motor moving. Now, when I approach the sensor to certain distance, the motor will move. When I move away, the motor will close. And then I can also go and just press the center button, and you see I'm moving to 90 degrees, and then I'm gonna do the plus, so I'm gonna do plus 10. Notice the servo motor moving, goes gradually. And then you can also see that the serial monitor is showing what we're doing right there. So let's just look at it clearly. Alright, now I'm at 180 degrees, so it doesn't move anymore. Now I want to close it. I want to go negative, just like we showed last time. It's going to decrease by 10 and so on, but I want to go faster, so why don't I just press the center, get it to 90, and then I can close it. But if someone comes in and approaches the door, approaches the sensor, then go away. All right. So this is very interesting project that we've just worked on right now. I'm gonna show you one more time. All right, the sensor is very sensitive, so I'm making sure the wires are plugged in, all the cables are plugged in properly, and I'm gonna show you how I set up the NodeMCU, because actually I'm using a NodeMCU here, but let me just show you this one more time. So I'm gonna approach this. Let me use any other obstacle. I'm gonna approach. Now it tells you that someone is at the door. If you look at the let's look at the Nextion editor clearly. Let's see what is showing us here. You can say now it says never mind, they are gone, but if you can look here, see never mind, they are gone. So we're gonna approach one more time. Someone is at the door. Never mind, they are gone. Right. So then you can write whatever you want. And again, when I press it, I get different values. But this is 90, and I can go 80, 70, 60, 15, and so on and so forth. And I can just go here and alright. Okay, so let me show you how we were able to build this. Okay, so I'm gonna get the camera off. I'm gonna get the camera off the stand, and I'll show you the setup. Alright. Right, so here's the setup here. You have the NodeMCU. Let's just make it a very small. That's the NodeMCU, and we have the former cables or the connections from the last episode the same way it was, but we now added 2 more wires. We had the trigger pin and the echo pin added, so that's pins GPIO 14 and GPIO 12. We added those, and then obviously we need 5 volts for the sensor, ultrasonic sensor. To achieve that, we have this that came. I'm gonna unplug it now. But this piece came with the Nextion editor. So for some reason, the way they designed it, it has pins on both sides, both up and down. All right. So we just use that to power both the Nextion editor and the servo motor. Right, and then we had to use 2 micro USBs. One of them goes to the laptop for programming the NodeMCU, and then the other side of the other USB from the computer then goes to this power port, if you will. And then from this power port, we're able to split the power to the Nextion editor, and from this power port, we're able to split the power to the Nextion editor and the ultrasonic sensor. All right, I'm gonna put it back and I'll just demonstrate one more time. All right, so I'm gonna plug in the power. All right. Alright, so really we haven't used a lot of wires here. In total we have 7, 9, 11 wires. In total we have 11 wires. From the Nextion editor, sorry, we have 4, and from the NodeMCU we have 7. So we have 7 wires from the NodeMCU, the 2 for the signal that go to the Nextion editor, and then the 3 that go to the servo motor, right here, and then the other two that go to the sensor we're using here. And then for the power, we took everything from the power port, if you will. Okay, so I'm gonna plug this back in. Alright, so let's demonstrate this one more time. Good. And in our next episode, we're going to be looking at using other sensors. So it's going to be the same, just going to be replacing the sensors. So we're going to do maybe sound sensor, or maybe light sensor. We're going to use light sensor, like photoresistor. We're going to use that to sense how bright a light is, and then based on that we can turn on the open the door, close the door. We can use this to drive a blind, and so on and so forth. Alright, thanks. Alright, thanks for sticking around to the end. That'll be it from us today. Please, if you have not subscribed, do so right now, and don't forget to like and share this video. Until we come your way again with more contents, stay enthused.